All right, today we are diving into something that is absolutely essential for making sense of data: relational joins. This is the real magic that lets us connect all these different pieces of information to see the big, powerful story they tell when you bring them together.
You've probably been there, right? You're staring at this massive spreadsheet. It's got customer info, it's got every single order they've ever made, all just jammed into one giant table. And, at first glance, it might even look kind of organized, but it gets messy really, really fast.
Because you see, sticking everything into one single flat table like that, it seems simple, but believe me, it quickly turns into a major headache. We're talking about inefficiencies and a whole lot of errors. And here's the heart of the issue. It's called the one-to-many problem. So you've got one customer, but they have many orders. In that single table, you end up repeating that customer's name, their address, everything over and over and over again for every single purchase. It's just a recipe for typos and a huge waste of space. And this is not a small thing. Get this, data professionals can spend up to 80% of their time just cleaning up the exact kind of messy, repetitive data that these flat files create. That is an enormous amount of work you have to do before you can even get to the fun part, the actual analysis.
So how do we get out of this mess? Well, the solution is actually really elegant and incredibly powerful. We split our data up into nice, clean, logical, separate tables.
And this right here, this is the aha moment. On the left, you've got that messy, repetitive table we've been talking about. But on the right, you have this beautiful solution. It's a process called data normalization. We just create two clean tables, one that only holds customer info and one that only holds order info. And just like that, all that repetition is gone.
But wait, you're probably asking, how do these two separate tables know how to talk to each other? That's where this little hero comes in, the primary key. Think of it like a unique passport number for each customer. That ID number only shows up once in the customers table, but we can use it, we can reference it in the orders table, so we know exactly who made each purchase. It's the link.
Okay, so we've done the smart thing. We've split our data apart to keep it clean and efficient. Now, we need a way to bring it all back together so we can actually get some meaningful answers.
And this is the million-dollar question, isn't it? How do we ask something simple like, show me all the products Alice has ever bought, when her name is sitting in one table and all her orders are sitting in a completely different one? The answer is relational joins. A join is basically a command that looks at that shared passport number, our customer ID, and it perfectly stitches the rows from our two tables back together, but only when we ask it to. And here's where it gets interesting. It's not a one-size-fits-all kind of deal. There are four main types of joins, and picking the right one is all about knowing exactly what question you're trying to answer.
Okay, let's get practical. We're going to use these two simple tables for all of our examples. So on the left, we've got our customers. We've got Alice, Bob, and Charlie. Now look at the orders table on the right. I want you to notice two really important things. First, Charlie, who is customer ID 3, doesn't have any orders. And second, there's an order for a cherry that's linked to customer ID 4, but we don't have a customer ID 4. Keep those two details in mind.
Let's kick things off with the one you'll probably use the most, the inner join. Think of it like the picky one. It only brings back records where the customer ID exists in both tables. It's looking for that perfect overlap, the intersection of the two.
And boom, here's what we get. We see Alice and we see Bob. Why? Because their names are in the customer table and they have matching orders in the orders table. But notice who's missing. Charlie is gone because he doesn't have any orders. And that cherry order? Gone too because it has no matching customer. An inner join gives you only the perfect matches.
All right, next up is the left join. Now this one has a totally different philosophy. It says, you know what? Give me absolutely everything from the table on the left, that's our customers table, and then just bring in any matching orders you can find from the table on the right. And look who's back. There's Charlie. He's included in our results because he was in our left customers table. Now since he doesn't have any matching orders, those fields for order information are just empty, or what we call null. This is an incredibly powerful way to answer questions like, show me all the customers who haven't bought anything yet.
So as you might have guessed, a right join is pretty much the exact opposite. It says, okay, this time, give me absolutely everything from the table on the right, our orders table, and then just pull in any matching customer info you can find from the left.
And check out this result. Now we're seeing every single order, and that includes that weird cherry order. Since it doesn't have a matching customer in our customer table, the fields for name and customer ID are null. This is the perfect tool for spotting data entry mistakes, or what we call orphaned records. And finally, we have the big one, the full outer join. This one holds nothing back. It says, I don't care where it comes from, just give me all the records from the left table and all the records from the right table. It gives you the whole story.
And here it is. Everybody's at the party. We've got our customers who have orders, we've got our customer without an order, that's Charlie, and we've got our order without a customer, that's the cherry. This gives you a totally complete, reconciled view of your data. It shows you everything that lines up perfectly and everything that doesn't.
So you've got these 4 really powerful tools in your toolkit. The key then is just knowing which one to grab based on the question you need to answer. So let's just lay it all out nice and simple.
Think of this table as your ultimate cheat sheet. If you want to see customers with orders, use an inner join. If you need to find customers without any orders, that's a job for a left join. Want to find orders that have no customer and might be a data error? Use a right join. And if you just need to see absolutely everything, the whole picture, warts and all, you go for the full outer join.
See, when you step away from those messy, flat files and you start using the clean, structured power of relational joins, you really unlock a whole new world of analysis. So I guess the question I want to leave you with is this. Now that you have this toolkit, what hidden stories are just waiting to be discovered inside your data?